In this video, I'd like to talk about graphing the cosine function, or in other words, graphing the equation y is equal to the cosine of the angle theta. And in a previous video, we looked at graphing the sine function, which I can paste down below so that we can get an idea of what that looks like. And the cosine will essentially be a shifted version of the sine function. It's basically the exact same curve, just shifted pi over 2 radians to the left. So let me paste that in. And we've also seen in previous videos that when we take our sine function and we add pi over 2 radians to the angle, or 90 degrees, that this is equal to the cosine of theta. And this is often known as the periodicity identity. And with this identity, we can see that when we add pi over 2 radians to the independent variable, we get the cosine function. And if you recall from shifting functions, if we take a function and we add, let's say, some number h to it, we essentially shift the entire graph of the function left h units. So in the negative direction, h units. And in this case, we're adding pi over 2, meaning that we are shifting this graph to the left pi over 2 radians. And once we do that, we get the cosine function. And if we shift everything to the left, essentially you can see these points all just move left pi over 2 radians, we get the exact same curve, which I will draw in very roughly here. It's just everything is shifted for the curve. It's the same shape, though admittedly this is not drawn that great, but it is shifted left pi over 2 radians. But if we didn't know anything about the sine function, and let's say we didn't know this identity here, then we can also graph this function by simply making a table, putting in different values of theta to our function, and then plotting those points. And to do that, we'll need the unit circle. So let me clear up these pictures here, and we can start that process. So we have our unit circle, and we also need a table. And in this table, we're looking at different values of theta and different y values for our equation y is equal to the cosine of theta. And for theta, we can look at the key values, namely starting at 0, then looking at pi over 2 radians, which we know is 90 degrees. We can look at pi radians, or 180 degrees, 3 pi over 2 radians, 2 pi radians, though we can also look at the negative values as well. We can look at minus pi over 2 radians, minus pi radians, minus 3 pi over 2 radians, and minus 2 pi radians. And if we want, we can look at more values, but remember on the unit circle that when we have some point, we know it's x, y value. The x value is the cosine of that angle theta, measured positively going in the counterclockwise direction and negatively in the clockwise direction. And the y value is the sine of theta. But the interesting property of both the sine and the cosine function is that they are periodic. Essentially, the values will repeat every time 2 pi radians is added to the angle, or 360 degrees. And we can do that infinitely many times. And that's why we see that this function will essentially look like a wave. It will repeat forever if we let it. And we can also subtract 2 pi radians or subtract 360 degrees as many times as we want. So we'll just look at these key values between negative 2 pi and 2 pi, but if we want, we can extend this as far as we need to. Now, the cosine function, since it deals with the x value, we will basically be concerned with the x value of this point on the unit circle at any given angle. And we're starting with a 0 degree or 0 radian angle, which would be at this point right here. And we can see the x value or the cosine value is just 1 there. Though when we rotate this 90 degrees or pi over 2 radians, we are now up here. And this is at the point 0 for x and 1 for y. So the cosine here would be 0. And when we rotate pi radians or 180 degrees, we get an x value of -1 now. And rotating 3 pi over 2 radians or 270 degrees brings us to this point. And we can see again the x value here is 0. And once we rotate 2 pi radians, we go all the way back to this starting point, or 360 degrees. And we know at this starting point, at 0 degrees and 2 pi, the x value, or the cosine value, is just 1. Now going in the other direction, we can rotate -90 degrees, or negative pi over 2 radians, which brings us to this point where the x value, or the cosine of that angle, is 0. If we rotate minus pi radians, or minus 180 degrees, the x value here would be -1. Rotating -270 degrees, or minus 3 pi over 2 radians, brings us to this point. The x value there is 1. And subtracting 2 pi brings us all the way back around to this point again. And we know there the x value is just 1. So let me quickly plot these key points, and we will use a scale of pi over 2. So this will be pi, 3 pi over 2, and 2 pi, and so on. And this will be minus pi over 2, minus pi, and so on. And for the y-axis, we will use a scale of 1 for each of these tick marks. So this would be at -1. So let me plot those points. And now we just need to determine the curviness of this function. Do we just have straight lines to each of these points, or does it curve going between each of the points? And notice also that we have symmetry about this y-axis. It's a mirror image on either side. And you might recall the identity that the cosine of theta is equal to the cosine of -theta. When we put in the opposite independent variable, we just get back the function, which of course is the property of even functions.